Okay, so hello everyone. For those of you who do not know me yet, I am Jeremy. I am the export manager at Adeunis, and I am joined today with by Elsa, who is our product manager, and who was in charge also of the gateway development. So
Hello.
today, as you know, we are here to talk about Iris, which is the newest addition to the Adeunis portfolio, a LoRaWAN gateway for the European frequency band. So we are going to dive into the agenda for today. To begin with, we are going to, of course, explain the key features of Iris, the deployment options, because we implemented quite a few topics and features. We will then have an overview of the interface with pictures and also a video demonstration of the embedded LNS, LoRaWAN network server. And then we will end with a quick question and answer. Also, just so you know, we will be showing two or three polls to which you will be able to read the questions, respond, and we will then have a look all together on the answers. This would be very interesting for us and help us get some statistic.
And yeah, just to complete what Jeremy just said, the objective, sorry, for us with this webinar is really to show you how this gateway addresses three main challenges: the flexibility in the choice of the architecture, the simplicity, the easiness of integration, and the reliability, because the gateway is a critical part in a network.
So without further ado, we're just going to start off with really a few points of data. So for everyone's attention, in 2025, for example, worldwide, 7 million gateways approximately were deployed and installed. That was also about 400 million sensors. And from 2019 and 2025, 66% of the LoRaWAN networks that were deployed were LoRaWAN operated networks. So with the main players and partners such as Netmore, EveryNet, the Things Network, etc. The three key markets that we have highlighted, as you can see at the bottom, are the smart building, of course, the modernization of energy networks, and also industrial IoT, IIoT, for those who are familiar.
Yes, the LoRaWAN market really has reached a high level of maturity now.
Yeah, worldwide, which is very interesting. So really, I believe almost all of you already know, of course, what a gateway is. Just a quick sentence for the uninitiated. So Adeunis provides also LoRaWAN end devices, also called sensors, which take some data such as temperature and humidity and send them to a gateway. The gateway acts as a bridge that concentrates the data from many, many different endpoints and then transfers that to either a cloud, a platform, a network server, pretty much an IT system as a whole. So yeah, very, very quick slide just to make sure we are all on the same page. After that, we have implemented just a few, some of you might know that picture already, a few use cases within the smart building segment that Adeunis is really familiar with. The three main topics are, of course, let us put it this way: energy efficiency, reducing the energy consumption for water, gas, electricity, optimizing the maintenance operation and the processes, so being able to identify in advance an event or act quickly to do some repairs, for instance. And last but not least, of course, improving the user comfort within a building. That goes within our air quality, etc. So moving on to the gateway and pretty much the main features and benefits that are available. We have tried to get the device as agnostic as possible and as adaptable as well. So as you can see, we have a flexible architecture within the gateway. It is possible to do both data forwarding to an external LNS, such as the ones that we mentioned, TTN, Activity, Netmore, etc. And it is also possible to use an embedded network server that we have installed in the gateway. For your information, the embedded network server is actually ChirpStack. So I think most of you are familiar with it. We have optimized the integration as much as possible, allowing direct connection to servers via MQTT, MQTT-S, and HTTP and HTTP-S as well. You will see in a few slides also the performances of the gateway on a technical and radio level. We have tried to provide a very high quality device for a very interesting and competitive price. The gateway, the goal is for you and your customers to deploy as less as possible to cover as much ground as possible with fewer gateways. The gateway, as you can read, is IP67. So it is designed for both indoor deployment, but also outdoor deployments. It is manufactured in France, which we are very proud of, where Adeunis is located, of course. And it is also always connected. We have included several possibilities. You have, of course, Ethernet connectivity. You have also 2G, 3G, and 4G cellular connectivity, so covering most of the use cases. Last but not least, this LoRaWAN Iris gateway is compatible with not only Adeunis sensors, but all the sensors, the LoRaWAN sensors on the markets, Class A and Class C.
Okay, thank you, Jeremy. And so with that in mind, we can move on to the first poll.
Absolutely.
For this webinar.
So normally, if everything works well, you should be able to see the poll, and you should be able to, we will give you, I think, about a minute to have a read and respond to the two questions on this one, sorry, that we have implemented, and then we will have a quick check. Thank you very much. Okay, so some answers already, perfect. This way, it's not just us talking, it's also an exchange, which is very nice. A few more seconds, just so everyone can participate. Wait for the second question as well. And some people are changing their minds, which is good, no problem. There we go. Okay, shall we go?
Yeah.
Okay, I'm closing the vote now. There we go. And I'm sharing the results just to have a quick check all together. So the first question was, what type of project do you most see yourself using a gateway like Iris for? So as we can see, which is very interesting, the more responses were for smart building and BMS, building management systems. Metering and energy is a very close second. And then, of course, a bit of industrial, public sector, smart city. And we also have one person who is in discovery phase. So like I said, at the end, we will have question and answers. Feel free to ask any questions. This is exactly the topic. So first question, mainly smart building and BMS. Good. And the second question was, what is the most important criterion for you when choosing a gateway? So quite a few answers. Security and remote management is the first one, followed by connectivity and backhaul. So we will have quite a few things to say on this topic during the presentation. And of course, in the ease of installation and price, which is a predominant factor. So thank you very much for participating to this one. I will now stop the screen sharing on the results, and I think we can go back. Okay, we'll just need to reshare the presentation, and then we'll be okay. Okay. And sorry, a small live issue. There we go.
Okay, sorry.
And perfect. There we go. So in the next part, we are going to move to the features of the Iris Gateway and the performances that are available. So and sorry.
You can go ahead.
I was talking too much. So we'll take care of that part.
So from a technical standpoint, Iris, this gateway is built on a proven market-tested components. So we have the wireless cellular modem with 4G, 3G, LTE Cat1 connectivity. On the LoRa side, we use the same tech, S61302 concentrator, which is a well-established market reference, widely used by mainly by all manufacturers of gateway. So at the moment, we only support the European band. And the gateway comes with one internal LoRa antenna with an SMA connector. And in just a couple of minutes, I will show you the performances, the radio performance of this gateway. And for connectivity, you also have one internal cellular antenna with a SIM card holder and the port for Ethernet connectivity. On the firmware side, the gateway supports two network approaches, as we said, the packet forwarder mode connected to a remote LoRa server, or the embedded network server to build a private LoRaWAN network. So depending on your use case, it's just a simple one parameter configuration from the gateway web interface. So the gateway is compatible with Class A and Class C LoRaWAN sensors, basically any sensor on the market. It can also operate as a network server, so you can connect multiple gateways to one gateway with the embedded network server activated. We support, so the embedded network server is compliant with LoRaWAN 1.0.x spec and 1.1 spec. You can, of course, register devices one by one or a batch of devices. Remotely, you can also configure the sensors using downlinks. It can be one by one downlink or multicast downlinks. We also, so just to let you know, we carried out a long duration test with more than 300 sensors in our building. So 300 sensors registered to one embedded LoRa network server and communicating with different frequencies, different type of sensors, and we did not observe any operational issues at all. So you can use this gateway either for small deployment or larger one with more than 500 devices connected to the embedded network server. The data can be forwarded, as Jeremy mentioned, using MQTT or HTTPS, MQTTS or HTTPS protocols. And we also, to make the integration easier and simpler, we have developed some features such as the embedded codec manager and JSON transformer script. We will present in more details these two features, but the goal is really to simplify integration in an existing system when you use the embedded network server. So in the end, this gateway, it's not just a packet forwarder, a gateway to forward the data. It's really, the objective is to fit smoothly into an existing IoT architecture. So on this slide, you have a view of the radio performance of the gateway. So Iris has been designed to deliver very good reception sensitivity and strong radio reliability. So it's the two graphs you can see here on the screen, including in very demanding environments, for example, in the basements. So we carried out some comparative tests. So we have an anechoic chamber in our office, and we assessed the performance against other solutions on the market. So it's Multitech and MySite for these two graphs. The first graphs show the signal-to-noise ratio. It's a common indicator to assess the quality of the signal that is received from the sensors, and the closer you are to zero, the better is the performance. Okay, so you can see that the iris line is the green one, so we're on the top of the graph, so it's a good performance. And if you are for example at minus 15 dB in SNR, it's bad performance, let's say. This test, they show that in real conditions, the Iris gateway is able to provide reliable reception of sensor data, so better service continuity over time, and we can capture signals from larger number of sensors or located at greater distances. But of course, even if we have good performance, it doesn't mean that you don't have to to respect some best practices, okay, that can be ignored. For example, you need to put the gateway in an open installation. You need to keep spaces between the two antennas, around the two antennas, and to switch to an external antenna if you are really in a site on a site that is really constrained. So maybe Jeremy, you can show the box and the inside.
Of course. When, I hope we will see enough. This is what the Iris gateway looks like.
Yeah. So the enclosure is compact, as you can see, robust, designed to really for field installation. So we have several mounting options. You can put the gateway on a desk, on a wall, mounted on a DIN rail, installed on a pole. We have accessories for that, so it's really the installation is very flexible. We have an IP67 protection rating, so you can install the gateway in both indoors and outdoors environment, depending on the project requirements. The gateway is certified to operate over a range of temperature from -20 degrees to plus 55 degrees, so you can install it outdoor without any trouble. To protect the electronics against humidity and temperature variation, we have so dedicated specific cable gland ventilation, and for Ethernet we have this IP67 cable gland. So yes, everything is designed to operate in both indoor, outdoor environments. And if the gateway is installed on a site where an external antenna is required, we have dedicated outputs on each side for that purpose. And we also provide a step-by-step installation procedure online to use external antennas. And we can even provide as a kit the antenna, the cable gland. So this, for example, is a magnetic antenna for the LoRa interface. We have
three main
fiber
omnidirection fiberglass
antenna, and we also have antennas for the LT interface. So yes, with different lengths of cable, etc.
Just quickly show the inside as well. There we go. So I don't know how good it runs on the camera, but at any rate, all the pictures can be found within.
So you have the two internal antennas here, the Ethernet cable, the SIM card holder.
Oh, okay, there we go.
Yeah.
And everything, of course, is available on the website.
Yeah. And with that in mind, we can move on to the second call.
Yeah,
maybe
absolutely.
Let me just do it.
Do not worry, we only have 3 calls in total. I think this is the second one as well, just to try and get some information as much as possible. So there we go. And up, just give me a second. Okay, perfect. So same thing once again. Give you just I think 1 minute as well. For those of you who participate, thank you very much. This is actually not only just to entertain, it's very valuable data for us. Questions that us salespeople try to ask as much as possible. But the more we know, and since we have a good diversity of people attending and companies attending here, we think it's a good way to get your experience on these types of devices. So I'll let you 30-40 seconds to read everything and choose your responses, and then same thing, we'll analyze the results. Okay, quite a few answers, and I think we can move on. Okay, so let me close the votes and share the screen results. There we go. So thank you very much for your responses. The first question was, what type of connectivity do you prioritize for your deployments? A huge number of you.
Ethernet and cellular.
Yeah, absolutely. I have chosen Ethernet and cellular backup.
Okay.
So this is valuable. We will mention 1 or 2 things about this later on as well. Second question was, is the use of an external antenna a common requirement in your installations? Depending on the site, mainly, and for some of you, it's not an option, it's systematic. And one person said rarely. So, okay, quite a good information. As we said, we would provide antennas when needed. So if there's question on that topic as well, feel free to ask them at the end. And the last question was, what is the most common type of installation in your case? That was more varied. So indoor installation is the first, and outdoor is the second one. So really multiple scenarios also depending on the project. So like we said, the gateway is IP67, sorry. Indoor and outdoor are an option, absolutely. It's very, very interesting for us to see that we have a bit of everything in the chat on this topic. So
okay.
I'll stop the screen sharing. Thank you very much. And then, so as we said earlier, there are two main ways of using the gateway with the embedded LNS or the remote LNS architecture. Right now, here you can see on the screen normally a clear enough picture of the remote LNS architecture. So of course, on the left, we have the LoRaWAN sensors, Adeunis or another brand, the gateway, which will concentrate all the data from all sensors. And then to communicate with the remote LoRaWAN server, such as we said, TTN, Netmore, etc., you have the option of transferring the data through cellular or Ethernet, so 2G, 3G, 4G, as a reminder, using the protocols such as UDP, WS, WebSocket, and WSS, WebSocket Secure. So this will be from the gateway to the LNS, and then from the LNS to the end user IT, let's say. This will, of course, depend on the LNS itself and which one you are using. Moving on to the, yeah, okay, perfect timing. The next slide, just a quick words, a few words about the two packet forwarder features. We implemented Semtech UDP and also Semtech Basic Station. So UDP, I believe, might be the most common one that you may be familiar with. A few words, it is fast, simple to implement. It has all the basic security features that you might need. It can be less robust than some of the counterparts, but it is specifically suitable for proof of concepts and small to medium, let's say, scale deployments. And then we also have Basic Station, which is, as you can read, a more modern approach, embedding more newer.
It's more secured, based on a WebSocket, a secured WebSocket. Today, it's the packet forwarder type that is recommended by all the LNS provider. And on top of that, we also support the CAPS protocol to secure even more the communication, the data transmission, and the communication between the gateway and the external network server. Absolutely.
So just the last sentence would be that for both protocols, of course, there's an interface that's available with the APIs to send the data to the LNS. Data transmission is simplified as much as possible. So usually those are really amongst the top contenders of the options. Trying to catch up on the delay of the small technical issue. Moving on to the next slide. The embedded network server architecture. So very simple and straightforward. The main information that I provided before is we are providing ChirpStack as the embedded network server, LoRaWAN network server. So really everything is done locally, directly on and by the gateway, and is then transferred by cellular Ethernet and QTT MTTS. So the good things about this, about the embedded network server, on top of simplifying the deployments, is really that there's no hidden fees or license fees. ChirpStack is a very well-known standard nowadays within the ecosystem. It's specifically for, depending on the customer and also depending on the country, it allows to keep all the data in one place. So at the customer's premises or within the IT department of the customers, which can sometimes be mandatory to keep everything privately and avoid as much as possible external third-party providers for software. So that's the main thing. One of the features we are also really proud of in this new gateway is actually the codec decoding tool, the decoder library tool. So of course, all the Adeunis sensors are already decoded within the gateway. but we also wanted to remain, as I said at the beginning, as agnostic as possible. So any LoRaWAN sensor manufacturer that actually provides a codec library, a JavaScript library, the gateway, the integrated LNS will be able to take that library and decode everything locally, internally. So this would remove also the needs to do it with an external party software or through a platform if it is not convenient in your specific project.
Yeah, and we can also, of course, help you if you have any question, any trouble with the integration of this codec in JavaScript format.
Absolutely. And next, the topic that Elsa broached a few minutes ago, what we call the JSON transformer, actually. So this will allow you to sort and filter the data that you want to receive, or at least you want to preview. So as you can see, there's 5 quick steps. We allow the fact to reduce the payload by taking only the fields that are required from all the frames that the gateway will transfer and will process. You can retain only some of them. It is possible to rename and restructure some fields to match an existing scheme, depending on how your infrastructure is built and what the customer is interested in.
Yeah. The idea is really to adapt the format of the JSON to the requirements of your IoT platform, your application.
Yeah, or what's already being used. Yeah. Absolutely. Yeah. So yeah, I think it's pretty straightforward. You can filter, process, and adapt the data to your liking, pretty much. Now, normally we're okay. Moving on to unboxing and installation.
Yeah.
The goal for this is for you to understand. Sometimes it cannot be clear enough. So if and when you order an Iris gateway, what will you actually receive? What do we include within the box and the accessories? So as you can see, by ordering an Iris LoRaWAN gateway with Adeunis, you will receive the gateway itself, of course. You will receive an Ethernet connector plus the cable that goes with it. And we will also provide the external power supply that is certified with the gateway. Elsa showed earlier some of the accessories that we will also provide. So the LoRaWAN antennas, LTE antennas as well, DIN rail mounting kits. Anything, the main information is the basic box contents, Iris, gateway, Ethernet connector and cable, and power supply. You can absolutely start a LoRaWAN project only with what we provide to begin with. For some installations, for some locations, you will need a deported antenna, an external antenna. You will need something to gain more signal, for instance. So this is what we provide within the accessory lists as well. Okay.
Okay, so let me very quickly walk you through what the first access to the gateway looks like. So the goal here is not to go into every detail, but simply to show you that getting started is really straightforward and is structured. And then we will move on to the most practical part with the presentation of the web interface and the demo of the network server. So to begin with, you need a computer on which you will temporarily configure a static IP address in the same subnet as the gateway. So we provide all the default settings on the user guide. And so then you connect your computer to the gateway's Ethernet port and you power up the gateway. And then you just write down on the web browser the web address of the gateway, and after this first connection, you will have to set up your password to secure the connection to this web interface. So really first access, very simple, local access via Ethernet, local connection to the gateway. You set up the password, and then you are ready to configure the gateway.
Just a quick thing. I see that there's some questions. We will read them in a couple of minutes, if that's okay, during the Q&A.
So far, we have covered the main principles. So now we will move on to something much more concrete, show how This gateway is actually configured in the interface through the main state of commissioning and a demonstration, as we said, of the embedded LNS. So let me show you. I'm going to open the web interface.
There we go.
Okay. So connect. Long password. Okay. Okay, so the web interface has been designed to guide users simply through all the main stages of commissioning, operation, and maintenance of the gateway. So you have a clear navigation with simple menu on the left, and then you have the main information on the screen. So the first step in commissioning is to configure the IP connectivity. As we said, it can be cellular connectivity or Ethernet. And this flexibility allows the installation to be adapted to the site constraints, whether the gateway is deployed on a site that can be easily connected to the local network or not. So on the cellular side, you just need to configure the APN if it's required by the telco, the PIN code, the watchdog also if you want to keep the connectivity, the connection between the server and the gateway. On the LAN side, you choose how the IP address is assigned. It can be static IP or dynamic IP setting. And basically, yes, that's it. The second step in commissioning is to configure the system time. So for that, you have two options. It can be manual setting or automatic time setting using NTP servers. So these servers can be external servers, for example, google.com, or it can be internal NTP servers that you have on the site. And every 24 hours, we have an automatic update of the system time. Once the system time has been configured, the next step in the commissioning process is to secure the access to the gateway. So this is done in 3 steps. First, secure the access to the web interface, so that the credentials, the sessions are always encrypted during network exchanges. So this is done via this entry, menu entry. Then you can define which IP addresses are allowed to access the different services. So we have 4 services: web interface, the ping server, the packet forwarder, and the embedded LoRa server. So you select either to authorize all IPs or a specific set of IPs that can access the service over the mobile network, okay, through the cellular interface. And then we have the CA certificates page. So on this interface, we import the root certificates that are required to secure the outbound connections, such as MQTT, HTTPS, and secure WebSocket. So the next step is to put the gateway into service on your LoRaWAN network, selecting one of the 2 modes, embedded network server or packet forwarder. So you do this very simply, selecting the mode from here.
So this just, I'm noticing that because of the screen sharing, you cannot see the menu when we open. So very sorry about that. So we can just, okay. We can just tell them out loud. So you have, of course, as we explained, basic station with LNS, basic station with CAPS. And the third one also was, yeah, okay, sorry, packet forwarder, UDP. Yeah. Perfect, there we go.
Yeah.
So, sorry, go ahead. No. Just I noticed it, so I thought
I didn't. No, okay. And so once the commissioning is complete, you can switch to the operational mode. So on the maintenance section, you have all the all the features for maintaining the gateway up and running. So you have the logs, you have the restore, backup, configuration functions, you have the firmware updates, and so on. So okay, that's it. A very brief introduction to the web, to the configuration of the gateway using the web interface.
Okay, switching back to the presentation.
Yes.
There you go. Perfect. Okay.
Maybe we can move on to this.
Yeah.
Because we already talked about the packet forwarder with the two forwarders. So let's now switch to the most practical part. I'm going to show you how to activate the embedded LoRa network server, register the sensors, decode the data, send downlinks, route the data to an IoT platform. So we have recorded the video, but I will make the comments live, so it should be okay. Okay, and for the demo, okay, we assume that all the additional commissioning steps that I just mentioned are already have been completed. Okay, so the server is enabled from the web interface. Okay. So it's what we are going to see on the screen. So you just select the LoRa server mode on the settings, and then you fill in all the site metadata and the timing parameters. So we have few. Okay, here you can see the different options. So you have a few parameters to fill in. The keep alive, stat interval, the latitude, longitude of the gateway if you want, and then you configure the HTTPS port, and then you define the username and password for the network server dashboard. Then once the embedded network server has been enabled from the web interface, you will have a new entry on the menu, network server, and when you click on it, it opens a new window, and you just log in using the credentials you just defined, okay? And you will have an access to the LoRa server dashboard on a new browser tab. So that's what we can see here. So the Iris gateway running the embedded network server is automatically pre-registered. So we can see here we have this gateway registered. And to access the gateway details, you just click on the gateway entry and in the menu, and you select the gateway. And it's also from this interface that you can register additional gateways that will forward their frames to the network server. And so now I will show you step by step how to create an application, register sensor, and do the uplinks. Okay, so once you have checked that the gateway is registered and in a correct state, the next step is to configure an application. What is an application? It's a group of LoRaWAN devices, so sensors. Typically, it's grouped by use case, function, location on a site. Okay, and all these sensors inside the application will route their data to the same server. Okay, so by default, the server creates an application automatically when the gateway is registered on the LoRa server. So we have an entry in the menu, applications, and you click on this application to edit the configuration and to view all the details of the application. So now it's empty because it's a new application, but you can view the list of associated devices, add a new sensor. You can create, manage multicast groups to send downlink to many sensors at once. You can manage the relay nodes and the device operating through a relay, and you can modify the application settings. So it's basically the name and the description of the application. So the overall logic remains very close to a standard LoRaWAN workflow, which means that if you're already familiar with some gateway on the market, you will feel at home immediately with this process. So once the application has been created, the next step is to create a device profile or assign an existing one for each type of sensor that will communicate its data to the LoRaWAN server. So for that, you have a device profiles entry to create a new profile or access to an existing one. So for Adeunis, all the profiles are already included inbuilt when you buy the gateway, but you can add device profile for basically brands. Any type of sensors. And so you have on the device profile, the device profile brings together the LoRaWAN specifications. So you have the region, the MAC version, the RX windows, etc. You have the codec, you have the measurement mapping used by the server. And so, as I mentioned, it's mandatory to create or to assign a sensor to a profile when you add a sensor on the gateway, because the server will rely on this profile to interpret the downlinks, the uplinks, into the downlinks, decode the data, of course, etc. So this is it's a key step affecting the correct interpretation of the messages and the quality of the data usage. And as we said, we can help you if you want to add additional codec in the gateway. So once the application and the device profiles are in place, and you can now register sensors in the embedded network server. So for that, you can do it via this interface, so it's one-by-one registration. Okay, so for the demo, I register a temperature and humidity sensor, the comfort, for if you know our product portfolio. So you just tap it, write down the name, the description, the keys for the connection. You associate a device profile, and it's done. So you can do it one by one, the device registration. And of course, you can also add a batch of sensors. And this is done using what we call the bulk device import function. So you can import, so it's what is displayed right now. So you can do it one by one. And using the bulk device function, you can import or remove a large number of sensors in a single operation using a JSON file or a CSV file. So you just download the template, then you add the information of your sensors. So it's just you have columns to complete, and then you just copy the file on the web interface, and then the import is done, or the removal of the sensors is performed very easily. Okay. And at this point, all that is left to do is to start the sensor. So for example, here, so as I said, I'm using a comfort, temperature and humidity sensor from Adeunis. So when you start the device, the sensor, it will join the network. You will have the join request, join accept frames, and then we will begin to see the frames directly in real time on the interface. So let's see that. Okay. So this is a view of the IoT configurator or tool for to configure and start the sensors. And then we will see here the first frames. Okay, so we see we have the join accept and then the first data coming from the sensor. So you can also, of course, see the decoded data directly. It's because I have added my device profile and I have a codec already for this sensor. So if I go on my sensor and on the events tab, I can see the decoded data. So here it's the temperature value and the humidity value, for example. And this decoded data, they appear also in the dashboard and in the sensor measurement tab, if you want. You can send a downlink, of course, from the server to the sensor. So to access the downlink editor, it's yes, you just go on the sensor and you have a queue tab. You build the payload. It can be in hexadecimal format, base64 format, JSON. So in this example, I just changed the transmission period to 10 minutes. And then you just queue the downlink. And of course, if the sensor supports this feature, you can send a multicast downlink to a group of sensors. Right. Okay, and so once the LoRaWAN network is configured and both the gateway, the sensors are online on the network server, the last steps is to forward the device payloads, decoded or not decoded, it's up to you, to your IoT platform. So we said it can be, as we said, it can be via HTTPS or MQTT. And so you just select the integration mode on the gateway console. And then, so on the demo, I just select the HTTPS forwarding. And of course, as we said, you can use the JSON transformer script to adapt both the data format and the routing logic to your IoT platform. So, for example, you can remove unnecessary fields. You can rename or group some fields. So this is a view of the JSON transformer. You can add metadata on the payload. You can change the MQTT topic. You can everything. Yeah, it's really flexible, and you can do. It's another way to adapt the format, and you can do you can do it with Node-RED, or you can do it with a JSON transformer, for example. And I think that's the end.